What is differentiation? It is a method that used to compute the rate of change of a function fx. It is also to solve the maximum and minimum values.
Question 1 is, explain the meaning of differentiation and what are the technique of differentiation. Next is question 2. Find dy dx for the following function: a, y equal to 2x squared exponent power of sine 3x, and for b, y equal to 3x squared minus 1 over sine x. For question 3, given x squared exponent power of 4x plus y minus sine squared 3x minus ln y squared equal to 0. Find dy dx using implicit differentiation. And the last question is, use linear approximation to estimate the value of cube root 63.99 plus 1 over square root 63.99. Correct to 3 decimal places.
Explain the meaning of differentiations and what are the techniques of differentiations. The meaning of it is the process of calculating the derivative of functions. A derivative represents the slope of tangent line to the curve at a given point. What are the techniques of it? First of all, we have power rule, second, product rule, third, quotation rule, fourth, chain rule, fifth, implicit differentiations, and lastly have logarithmic differentiation.
Hi, it's me Arya. Now let's do question 2, which is find dy dx for the following function. For question A, it is y equal to 2x squared exponent sine 3x. For this question, we need to use product rule, which is dy over dx equal to u v prime plus v u prime. So for u is 2x squared and for v is exponent sine 3x. Now we differentiate u, it will become 4x, and for v prime, it will become exponent sine 3x multiplied with cos 3x multiplied with 3. Then we substitute the formula, it will become 2x squared multiplied with exponent sine 3x multiplied with cos x multiplied with 3. Plus exponent sine 3x multiplied with 4x. And then the final answer would be 6x squared exponent sine 3x cos 3x plus 4x exponent sine 3x. For question B, y equal to 3x squared minus 1 over sine x. For this question, we need to use quotient rule, which is dy over dx equal to vu prime minus uv prime over v squared. Then, we will take 3x squared minus 1 as u, and for v, we will take sin x. Then, we differentiate 3x squared minus 1, and then it will be 6x, and for v, after we differentiate, we will get cos x. Next, we will substitute the formula, and then it will become sin x multiplied with 6x minus with cos x multiplied with 3x squared minus 1 over sin x squared. And then, it will be 6x sin x minus with 3x squared minus 1 cos x over sin x squared. Then we expand the equation, it will become 6x sin x minus with 3x squared cos x plus cos x over sin square x.
For question 3, given x squared times exponent to the power of 4x plus y minus sine squared times 3x minus ln times y squared equals to 0, find dy over dx using implicit differentiation. Firstly, for x squared times exponent to the power of 4x plus y, we need to use product rule. For u, we take x squared, and for v, we take exponent to the power of 4x plus y. For u prime and v prime, we need to differentiate, and we got 2x for u prime and exponent to the power of 4x plus y times 4 plus dy over dx for v prime. After we got u, v, u prime and v prime, we need to apply it to the product rule, which is u times v prime plus u prime times v. Next, we differentiate negative sine squared times 3x. Then we will get negative 2 sine times 3x times cos times 3x times 3. And then we expand the equation and we will get negative 6 sine times 3x cos times 3x. Lastly, we differentiate negative ln times y squared and we get negative 2y over y squared, and then we need to separate the y to dy over dx. By that, we will get negative 2 over y dy over dx. Lastly, we combine all equations and make it equal to 0. And then we need to separate equation that have dy over dx to the left and make sure that equation went to the right, change right symbols. Next, we factorize dy over dx, which we get dy over dx times x squared exponent to the power of 4x plus y minus 2 over y. Lastly, we find dy over dx by moving the equation on the left side to the right, and then the answer we will get is negative 2x exponent to the power of 4x plus y minus 4x squared exponent to the power of 4x plus y plus 6 sine times 3x cos times 3x over x squared exponent to the power of 4x plus y minus 2 over y.
For question 4, we will use the linear approximation formula, and that is f times x naught plus delta x equals to f x naught plus f prime x naught times delta x, where delta x equals to x minus x naught. For the first expression, 63.99 cubic fx equals to x to the power of 1 over 3. We'll choose an easy value. X naught equals to 64. Delta x equals to 63.99 minus 64 equals to negative 0.01. Then f times 64 equals 4, where f primes x equals to 1 over 3x to the power of negative 2 over 3. Evaluating at 64 gives f prime 64 equals to 1 over 48. Applying for the linear approximations, f 63.99 equals to 4 plus 1 over 48 times by negative 0.01, and you will get 3.99979. Next, we estimate 1 over 63.99 square root, where gx equals to x to the power of negative 1.2, x naught equals to 64, delta x equals to negative 0.01. We have g64 equals to 1 over 8 equals to 0.125. G prime x equals to negative 1 over 2x to the power of negative 3 over 2. Evaluating at 64 gives g prime 64 equals to negative 1 over 1024. Using the formula, g 63.99 equals to 0.125 plus minus 1 over 1024 times by negative 0.01 equals to 0.12501. And for the final answer, we will get 4.12480. You have to round it to 3 decimal places. The final answer is 4.125.
In conclusion, the techniques of differentiation are essential tools in calculus that allow us to understand how functions change and behave. Throughout this presentation, we have explored several important methods such as the logarithmic differentiation, exponential functions, quotient rule, product rule, and chain rule. By applying these techniques, we can solve various mathematical problems involving rates of change, slopes, and estimations more effectively. Mastering these skills is crucial for progressing in calculus and for tackling real-world applications that rely on accurate mathematical modeling.